Welcome to the friendly guide for moving from Excel to R. Today we're going to talk about charts, and specifically ggplot. Ggplot is a package in R which has dozens of different visualizations. It also has a theory behind it. It's called the grammar of graphics, hence the name ggplot. I'm going to put some related links to the theory in the description of this video. In a nutshell, the theory says that you use aesthetic mappings to describe the relationships of variables. I'm going to demonstrate this using two types of plots, histograms and scatter plots. First, I'll show you the Excel equivalent of histograms, and we'll carry on from there. As you can see, I've already opened up an Excel file with penguins data. I've shown this in previous videos as well. This data has different quantitative variables, for example, build length, build depth, and flipper length, all of which are continuous variables that can get different values. Histograms are used to show the distribution of continuous variables. So let's try and make a histogram for build length. All we have to do is check this column here and insert this histogram. Looks simple, doesn't it? It's not very complicated in R either. So let's move on to R and see how we can make this. I've already let's delete this code here. We don't need it. Let's do it together. First, I'm going to load two libraries. The first library is the Palmer Penguins library. Once I've loaded it, I get this table here, which is called Penguins, and it has the same data I've shown you earlier in the Excel. Next, I'm going to load the Tidyverse library. The Tidyverse library, once loaded, also loads the ggplot2 library, which is actually the library we're going to use now for the plots. So all we have to do in order to make a histogram is use this function called ggplot, tell it to use the penguins data, and now we have to create an aesthetic mapping. An aesthetic mapping means that I'm going to use another function within the ggplot function called AES, short for aesthetics, and I'm going to tell it to map the variable called build length millimeter into the x-axis. That's the only variable I'm mapping. I'm mapping the build length into x. The y is going to be computed by the function itself. So in itself, this function is not enough. Once I run it, you'll see I get a clean canvas with nothing in it. But we said we wanted to add a histogram. So we have to add another function. It's kind of like adding another layer. So in ggplot, these layers are called geometries. So I'm going to add another geometry. All geometries start with the geom and underscore, and we're going to add a histogram. So once I run these two lines here, we'll see a histogram pop up. And now you can see this histogram is slightly different than the one we've seen in Excel. And the reason for that is that R picks different default values for the resolution of the histogram. And it also says as such. You can see that R is saying, I've chosen 30 bins for the visualization. And you can pick better values if you want to. So let's try and pick a different value. We're going to add this argument called bins and tell it to pick, let's say 10 bins. So you can see we got a completely different visualization here, completely different histogram. And if we increase the number of bins, for example, for 40, we increase the resolution, and again, a completely different chart. Another thing we got here is a warning message, which says, I removed two rows containing non-finite values. So you can see that this table here has some NAs within the build length we're trying to plot. So that's what it's saying. It has two NA values, which he omitted from the chart. Okay, not very complicated. Let's try another chart type. And we're going to try a scatter plot. A scatter plot is extremely useful when we want to illustrate the relationship of two continuous variables. So let's move back to Excel. And we've got bill length here and bill depth. Let's say we want to illustrate the relationship of the two. So we're going to add a scatter plot, and let's delete the thing here. And we got it. Obviously, we can also customize this a bit and make it more beautiful, but it's not our goal here. We're going to show how you can do this in R. So this scatter plot only shows on the x-axis the bill length, on the y-axis the bill depth, and we can see the relationship looks somewhat linear. So okay, let's jump back into R. All we have to do is again use the same functions or similar functions. We start the same way, only this time we have different aesthetic mappings. We're going to map the bill length into the x-axis as before, only this time we're going to map the bill depth into the y-axis. And again, I need to add a geometry, so I'm going to add the point geometry. Once I run this, I get the scatter plot. You can see that R is already zooming in on the interesting part of the plot. Like in the Excel, we got something which start from 0, but all this area here is not interesting at all. And in R, we're already zoomed in on the interesting area. The selection of the axis can be customized, but the default values are usually very good because it's based on the range of the data. So I want to show you another thing. I said earlier that we can map different variables to different axes, and that it's called aesthetic mappings. The interesting thing here is that the relationship of bill length and bill depth is also dependent in the type of penguin, and we have a variable called species here. So going from this chart to a chart which also shows the intricacies of species is very simple in R, and it's not very simple in Excel. Like in Excel, you'd have to work a bit to get the data into the right into a proper form, and actually the data is already in what we call the tidy form. So all we have to do is tell it to, let's say, map the species variable into a color aesthetics. So color equals species. And you can see here that R already added the legend and colored the points and made everything. And now we can actually make sense of it. We can see that the relationship is different with different species. Like the Adelie has a higher slope than the Gentoo, and completely different values of these variables. Now, another nice trick is we can also very easily add a linear trend for these points. So like we can do another layer here, which is called stat smooth. And let's use method LM. This tells R to use a linear trend, like a linear model. Actually, it's also the default in this case. So even without stating this argument explicitly, I would get the same result as I got here. And you can see that R also added a linear trend, so we can see the relationship that these scatter plots induce. So hopefully I got you thinking about using R and ggplot for graphics. If you want to learn more, there's a very useful cheat sheet here, which you can load. Like when you go to help, cheat sheets, data visualizations with ggplot2. And it redirects you to a website. So this cheat sheet here is very useful when you want to identify the proper chart type for different use cases, like two variables, one of them continuous and the second as well, or one discrete and another continuous, or one variable as we use the histogram, which you can see here, and you can explore the high flexibility of ggplot. So hopefully you got enough interesting things here that you can start with. And there you have it, charts made easy. So as usual, if you like this video, click the like button, subscribe to my channel to get notified when I publish new videos like this one, and have a great day.